right, we'd already done A yesterday, is that correct?
Yeah.
And I don't think we made it to B. Did we make it to B or no?
No.
No? All right, cool. So for part B, we're looking at a new function, capital R. And capital R is f minus g. We want to find r prime of 2. So r prime ought to equal just f prime minus g prime. And so if we're going to evaluate r prime at 2, then we need to evaluate this at 2. So this would be f prime of 2 minus g prime of 2. First off, g prime of 2 is in the chart, so g prime of 2 is 4, right? And then we will use the calculator to figure out what f prime of 2 is. So we're going to use the calculator for that, and we'll subtract 4 from whatever we get. So let's make sure we remember how to do that. Can you guys see the calculator now, hopefully?
Yeah.
All right, so in the math window, option 8 is the derivative. It's the derivative with respect to what happened there. The derivative with respect to x, there we go. And the function, I believe, was x, what was it, x sine of the square root of something?
Square root of 3x squared plus 5.
3x squared plus 5, okay. All right, and we're trying to evaluate that at 2, correct?
Yep.
And if we subtract 4 from that, we should end up with negative 6.449. How's that sound to everybody? Is that what you all got when you did that?
Yes.
Spectacular. Hold on 1 second. I gotta do something for my kid real quick. Of course, that whole time during the quiz, he didn't need my help, but now he does. I'll be back in half a second. Okay, sorry about that. All right, so for part C, we are looking at another new function, capital S, which is now f times g. And so for f times g, we'll have to use the product rule, which will be f g prime plus g f prime. And we'll have to use the calculator to evaluate all of this at x equals 4. So f of 4 will be from our calculator, 4 sine of root, whatever that is, sine of root 53, it looks like, times g prime of 4, which is 1, and then plus g of 4, which is 5, and 5 f prime of 4. And you plugged that all into your calculator with any luck and got an answer. What was your answer for that?
I got 25.455.
25.455. Does that sound good to other people?
Yes.
Yeah, that's what other people got. All right, cool. Any questions on that? Just a matter of knowing the rules and being able to plug it in and use the calculator. All right, and then for part D, what rule do we need to use?
Quotient rule.
Quotient rule. So G, denominator, times derivative of numerator, minus numerator times derivative of denominator over denominator squared, and we're going to evaluate that all at x equals 6. Is that right for this one? Yep. G prime of 6, so at x equals 6. So g of 6 is 2, and g prime of 6 is negative 3. So this will be 2 f prime of 6 plus 3 f of 6 all over 2 squared. So that's a minus 3 for the g prime, so we'll make that a plus 3. Everybody good with that?
Yeah.
All right, and what did we get for an answer there?
Negative 6.485.
Negative 6.485, you said?
Yes.
Everybody else agree with that? Any questions or issues with that one? All right, that should be good for that one. Here is one more for you guys to work on. So this one shouldn't take too long, I don't think, but it's got a couple little conceptual things I want to make sure we talk about. So I can give you about 8 to 10 minutes to look at it, and then we'll go through it. Sound good? You guys can all see that problem, right?
You can see it.
All right, you got about 8 minutes, maybe 10 minutes to work on this, and we'll talk about it. Ready, go. So for part A, it wants us to approximate the value of f prime at 5.5, so the derivative of f at 5.5. We need to pick some interval of x values that includes 5.5, but that doesn't get here past this value at 6. In fact, we can't even use this value at 6 because our function changes nature there. So it goes from being this concave down function to this linear function, right? So piecewise defined function. So we can't use 6 in that. We have to use something below 6. So we could do the interval from 5 to 5.5 would be our best bet here, even though we don't actually have anything above 5.5 to use. So we can do 3.244 minus 3.455 over 5.5 minus 5. Good or no?
Good.
And what did that come out to be? I think it was like negative 0.422 or something like that, or 442.
For negative 4.422.
Negative 4. No.
Oh, negative 0.422.
Yeah, okay, that's what I thought. All right, negative 0.422. Everybody feel okay about that? You could have also used the interval from 4.5 to 5.5, or the interval from 4 to 5.5, and you might have gotten a different answer. But any of those answers would have been acceptable on the AP test, just as long as you didn't use a value at 6, and you couldn't even use the value 6.3 because that point doesn't exist. So don't use a point that doesn't exist to try to help you find the average or the instantaneous rate of change, to approximate the instantaneous rate of change. Does that make sense? All right, for part B, we want to know if there's a value of x between 0 and 6 such that this limit equals 0. And what is this limit right here?
That's a derivative.
The derivative of f of x, right? That's f prime of x. So we want to know, is there a place between 0 and 6 where f prime equals 0? And what should the answer to that be?
Yes, because it says there's a horizontal tangent.
Right, yes, it's at x equals 4 because there is a horizontal tangent line at that point. The problem specifically tells us that there's a horizontal tangent line there, right? Everybody good with that? All right. For part C, we got 3 different things to figure out. First off, we want to find the limit as h approaches 0 from the right of f of 6 plus h minus f of 6 over h. So that's still the difference quotient, except it's the difference quotient when x is 6, right? And it's only coming from the right. So what this is f prime of 6 from the right. So we're looking at the derivative of f to the right of 6, coming all the way up to x equals 6. And what is that value? You should be able to find that value just by plugging in some numbers. What do you get if you do that? You get 0.5 minus 1 over 7 minus 6 to find that linear slope. And what is it? Comes out to be negative a half. Any questions on that? Everybody okay with that?
Where did you get the 0.5?
From 7, 0.5 and 6, 1.
Oh, got it. Okay.
All right, now for the second piece, this is the same thing, but this is now f prime of 6 from the left. Now it's okay to have a limit if the point doesn't actually exist, but can we have a derivative at a point where the function doesn't exist? Can we have a tangent line at a point that doesn't exist? Can we draw a line tangent to the function there where there's no point?
No.
Right, so we have to say this does not exist because the function that comes from the left of 6 doesn't exist at x equals 6. And so if that's the case, then what must be true about the two-sided limit or the actual derivative f prime of 6? It certainly can't exist because the limit from the left and the limit from the right are not equal to each other. Does that make sense or no?
Question. So if it wasn't a linear line after when it's bigger than 6, could you still take the limit and find like an actual value, or would it be a lot harder?
Without knowing the actual equation of the function, we couldn't get an exact value, but we could still, we could have still approximated the value to the right of it if we needed to, using, using the values that were given in the table, even if it wasn't linear. Does that make sense to answer your question?
Yeah.
Okay, cool. Any other questions on that?